of finding the first and last position of an element in a sorted array. We are given an array of numbers in sorted order, and we want to find a specific value in it. We need to find the starting and ending indices of that value. If the target value is not found in the array, we will return -1 at the both starting and ending indices. Let's consider some examples. Here, in example 1, the target value is 8, and array is given as 1, 3, 5, 8, 8, 10. So we are finding the 8 at third and fourth index. In example 2, target is 6, and array is given as 5, 7, 7, 8, 8, 10. We are not finding 6 in the array, so we will return -1 and -1 as starting and ending indices. Now the straightforward approach to solve this problem would be to scan through the array and keep track of the first and last occurrence of the target value, which would take O of n time. However, we can do better. We can solve this problem in O log n using modified binary search algorithm. Let's understand how regular binary search works with an example. Consider the input array as 2, 4, 6, 8, 10. The target value is 8. We start with left and right pointer to compute our middle element. In this case, the middle element is at 2. And the target value at index is 6, which is not the target value we are looking for. So we update the pointer accordingly to search in the right half of the array. The left pointer moves to index 3. So we will left with 8, 10, left and right. And our middle index becomes 3, which is our target value. We can stop binary search and return the index 3. Now let's modify the binary search to find both leftmost and rightmost occurrence of the target value. Consider the array as 1, 2, 8, 8, 10, and target value is 8. We start our regular binary search when we will find the target at the index 2. But we want to find the leftmost occurrence. To do that, we update the left pointer to be the same as the right pointer. And then we continue the binary search this time. This time the middle index is 3. The value is 8. We again the left pointer to index 3 to look for the leftmost occurrence. Now we have found the leftmost occurrence at index 2 and the rightmost occurrence at index 3. By applying this modified binary search, we can find our target value in O log n time. So now let me show you the code. First, we need to create a helper function to perform a binary search for us. We will pass in the nums array and the target value we are looking. Additionally, we will include a third variable called left bias. If left bias is false, we assume a right bias result, meaning we are looking for the rightmost index. Conversely, if left bias is true, we seek the leftmost index. Now let's set up our left and right pointer for the binary search. Left will be initialized at 0 and right will be initialized at nums.length -1. The binary search process will continue as long as left is less than right. So less than equals to right. Next we will compute our middle index, which is essential for binary search. We will calculate it as middle equals to left plus right minus left by 2. After finding middle index, we can check the target is greater than the number at the position. If it is, we update our left pointer to middle +1, indicating that we need to search the right. On the other hand, the target is smaller than the nums of mid, then we will update our right pointer to mid -1, indicating that we need to search on the left. If we find the target value, we store its index in a variable called I and we will initialize I as -1. And whenever we find the middle index, we set I to mid index. However, even if we find the target, we will continue the binary search based on the left bias condition. If the left bias is true, indicating that we want to find the leftmost index, we will update our pointer to search towards left. If left bias condition is false, indicating that we want to find the rightmost index, we will update our pointer towards right. Finally, we will return our left and right pointers. With the binary search function now modified to include a bias condition, we can proceed to find the left and right indices. We call the binary function twice. First for the left index, passing nums target and value as true. Then we will call it again for the right index, passing nums target value and false for left bias. Finally, we can return our left and right pointer. The target value is not found, the binary search function will return -1 as specified. Okay, let's try to submit. Okay. In conclusion, this binary search implementation offers an efficient performance and achieving the time complexity of O log n. I hope this explanation was helpful, and if you find it informative, please consider supporting the channel by liking and subscribing. Thank you.